Hello and welcome. If you watch this video, you're considered to take the course AI for Game Technology, and I will be one of the teachers. My name is Miltzow, and here I want to tell you a little bit about the course so to help you to take a decision if you want to take this course or not. So the aim of this course is that you're ready to write a thesis afterwards on topics related to games and AI. Specifically the two topics that we cover in the lectures in this course, which will be reinforcement learning and player modeling. Okay, let me tell you a little bit about myself. I lived in many different countries before I ended up here in the Netherlands. So I'm German and I grew up in Berlin. Maybe I should mention this. As my hobbies, I like dancing and take some dance course. I'm a member of some running group, and otherwise I just like to hang out with friends, play board games, meet up for dinner, stuff like that. So the course will be consist organizationally of a few parts. So there will be the core of it will be these 4-hour sessions that we will have twice a week. And these sessions will be like a mixture of different things. So there will be lectures, there will be in-class assignments, so things that they're graded and you have to do during class. There will be discussions, there will be poster sessions. So that will be maybe the biggest part of the whole course. Then for most communication, we will use Teams because everything like sending you material, you can ask questions, you can ask your peers. You receive grades. MS Teams is really good for this. We will use two more software items. One is DomJudge. So that's just a super good tool for automatic grading. So you upload something and it tells you already, oh, the program is running or it stops. For some of the assignments, we will use peer grading. So we don't know exactly which software, but we will look into this. And peer grade, we heard from colleagues, is good, but we're not so far yet to decide this. The schedule will be fairly tight. So the first week, unfortunately, we cannot give lectures, which sounds great. Like a free week of lectures, this means everything else will be more tight, right? So there will be weekly assignments, and we decided to usually make these hand-ins for Monday, just because we want to keep the time between you learn about the stuff and you have to do the hand-in very narrow, so that it's not like, oh, we did this 2 weeks ago, but no, like this is what I just learned 2 days ago. And the first 3 weeks will be about player modeling, and then the last 5 weeks will be about reinforcement learning. And we will see if we do a last assignment in the last week, then on Friday, so that you still have enough time to learn for your other exam, maybe for other courses that you take. So the grading will consist mainly of these homework assignments, which will be around maybe 80 to 90% for what you had in your homework, which will be mainly programming, but it will also consist of some theory. Then around 10% or maybe 15% of all the total grade is all these in-class assignments that you have to do in class. So you have to do a lot of things by yourself, and so if you can't program or you're weak at programming, then you probably will need to spend a considerably larger amount of time on this course. As I said, programming and writing things is what you have to do. Specifically, the in-class assignment, this is just written, often just on a piece of paper. So let me give some dates here, some numbers here. So the average grade last year was around 9. But that's only among the people who made it, who finished the course. 7 out of 20 people dropped out of the course. And the number of hours that students reported was very high. So a third of the students said that they worked 25 hours or more for this course. This was self-reported. Yeah, I think it is realistic. Some students thought this course was not such a huge time investment, so they said they had between 10 and 15 hours. Um, what I want to say here, the message is you can get a very good grade, but it does take a lot of time to do all the work. So I will teach the part about reinforcement learning. So let me start to tell you a little bit about it, but it will be the second part of the course. So the motivation for this was that I myself are not working on reinforcement learning, but I was just fascinated by this AlphaGo Zero, also because I play Go myself, and I found these techniques interesting. So I will try to give you these core ideas, some of the core techniques that are required to make this AlphaGo work. And unfortunately, because of lack of time, we will not manage to do all of those, but a bunch of them. Yeah, so there's a few key ideas. So you will have self-play, of course, is one of the core ideas. There's something called bandit agent. This is the idea that you learn about exploration and exploitation. You will learn about Monte Carlo tree search. So this is like planning, looking ahead in a specific way that's employed by AlphaGo, and you will train neural network. So these are, I think, some of the core ideas that are used there, and so we cover them also in the lecture. And you will learn from data and generate data. Okay, so we will the reinforcement learning part will be mainly in the context of a game which is similar to tic-tac-toe, but just a little bit bigger, like a bigger board. And in tic-tac-toe, you alternately claim spots, and here in tic-tac-toe you have like a winning shape. Here we can go with different types of winning shapes. And this has the advantage that we as a instructors, or me as an instructor, can make the game more easy or more difficult depending on the board size and the types of winning shapes that I choose. So here, for instance, blue has won because she achieved this shape. And yeah, so this was maybe some different types of board sizes, some different time constraint that your agent had, and we would evaluate you on according to some benchmarks that we would communicate to you that we started to do last year, and that was very successful because the students then really had a good idea on what they have to aim for. The second part is about player modeling. Julian Frommel will teach this. So before Jordi Vermeulen was teaching it, now Julian Frommel takes over and he chooses a new topic. And later in this video, he will tell you more about it. And so this will be now the first iteration of this new topic from him. I want to also tell you a little bit about looking back at this course. So it's now, for me, the fourth time I teach it. For Julian, it will be the first time. And the first time we taught this course, there were a lot of things going wrong, a lot of things that the students didn't like, and we got a general evaluation of a 5.0. But it was the first time we taught this. So I was not happy with this, as you can imagine. Then the second time we already widely improved, and we got a student evaluation of a 6.9, which means like it was okay, but it wasn't great. And then last year, the students were very happy with the course, and we received an average evaluation of a 7.9. And we also got great comments from the students. So really, check Caracal to read more about all of this. There, of course, we aim to improve this course every year even further. So, but of course, there will also be the struggle of introducing a new topic, and so there will be new experimentation, and again, we will adjust this course a little bit, and maybe certain things you will not like so much. Yes, check Caracal, and this finishes my part, and now Julian Frommel will tell you more about his part.
Hi, I'm Julian Frommel, an assistant professor in interaction multimedia, and I will teach the player modeling part of the AI for game technology course. Just for some background, my fields are human-computer interaction and games and player experience research with a focus on social interactions in online environments, user and player modeling, and applied games. And I want to give you a very brief overview of what to expect from this part of the course. In the player modeling part, you will be implementing games in Unity. You will learn how to do that, and then you will learn about the basics of player states and player experience and how to conceptualize difficulty through game parameters. Afterwards, we will implement methods to assess the player state with some simple methods and use that as input to player models, which we use to adapt game features. So after the course, you will be able to implement a simple adaptive game in Unity. And if that is something that interests you, you will probably like the player modeling part of the AI for game technology course. And I look forward to seeing you there.